Good morning, girls. I'll continue with the chapter Magnetic Effect of Electric Current. See, in the previous week, I had explained you about what is the magnet, what are the different kinds of the magnet, what are the different properties of the magnet. Then we studied about magnetic field and we studied about the magnetic lines of force, right? Then in the previous classes, we had studied about how do we find the direction of the magnetic field line with the help of right hand thumb rule. Okay, and we had studied about the straight conductor and we have studied about the circular loop. Okay, so I hope you have seen the videos and you have written all the explanations and the notes which I had sent you. And if still you have not seen, you have time, you can complete your work. Now today we are going to study about what is a solenoid, what type of magnetic field is created in a solenoid and how do they look like, and how do we find the poles of this magnet. Okay, so let's do that. See, this is a straight conductor, right? What is a straight conductor? Suppose this is a copper wire. You know what is a conductor? Current flows through it, and through this straight conductor, because it is a conductor, copper conductor, if I change and this straight conductor turned into a coil of this type. Okay, so this type of arrangement or this type of pattern is known as solenoid, whose length is greater than the diameter. Remember this. So what is a solenoid? A solenoid is a conductor in the shape of a coil, right, whose length is greater than the diameter. Such type of conductor is called a solenoid. Now we'll study how this solenoid becomes a magnet and what type of field lines are formed in a solenoid. So let us draw the diagram. This is a solenoid. Yes. Now if I complete the connections, the current will flow. Yes, the current will flow through this from the positive end, and this is a key. See that when you make this diagram, the key has to be closed, not open. So this type of current direction can be shown in the coil. Now what next? Yes, when the current flows in the solenoid, it will start behaving like a magnet. And when there is a magnet, it has a magnetic field line around it. Yes, so the magnetic field lines in a solenoid, they look like this. So see that when you make a magnetic field line, they should not intersect. So when these type of field lines are formed in a solenoid, you may connect this type of field lines as similar to the bar magnet. Because when we were studying the bar magnet, I had told you about these field lines. They form this type of pattern, and from north they begin and end at south, and inside the magnet they move from south to the north. And do you know why? Because they form a complete loop. Similar to this, these type of field lines are also created in what? In a solenoid. Now, in this, when the current flows from this side, this direction is a what direction? There are two directions. One is a clockwise and one is the anti-clockwise. So because the current in this direction is a clockwise direction, therefore this end will become the south pole and this end will become the north pole. So obviously if any substance is made a magnet, it will be having a magnetic field around it, and this magnetic field around it has a specific pattern, and this type of pattern is a parallel line pattern. Okay, so these type of parallel lines show that the solenoid, the magnetic field of the solenoid is uniform. Means the strength of this magnet is same at all the places. I repeat these 3 points. The type of pattern created in a solenoid are parallel lines, showing that the parallel field lines are uniform, or we can say that the magnetic intensity or the magnetism is same at all these points. Okay, now if I bring any magnet close to it, Suppose we don't know the poles. Suppose we don't know the poles. And if I bring a magnet, bar magnet close to it, if this part of the magnet repels, if there is repulsion, you will come to know that this is the south pole and this will be the north pole. Okay, so you can, with the help of a solenoid, you can come to know a bar magnet, the polarity of the bar magnet. Okay, so this is one use of solenoid. Then we can say that if the current stops flowing in the solenoid will lose its magnetic property, right? And it will not behave like a magnet, or it will not behave like a magnet. So basically, what is a solenoid? A solenoid is a conductor which is wound or in the form of the curls, right, like a spring. And when the connections are complete, when the current flows to the solenoid, the type of pattern of the field lines which is created over here is shown in the form of the parallel lines. These parallel lines shows that the uniformity of the magnetic field lines. Then one end will become the south pole and one end will become the north pole. Why this is south pole? Because the current is flowing in the clockwise direction, and in this the current is flowing in the anti-clockwise direction, and so it is a north pole. Then if we have to show the magnetic field lines, we will not intersect them, so sorry for this. We can make more field lines in this corner, and more field lines we can make in this corner. Okay, but you remember that the south and the north depends on the direction of the current. Okay, now you will study all this from the book. And what, did I forget anything? No. So this is all complete. There are three types of conductors: straight conductor, current carrying circular loop, and solenoid. You will now study the three types of the field lines, and I have taken out some questions for you. These questions I am going to send on the WhatsApp group. You will find the answers of these questions and try to write them in the notebook. So let me read quickly. First is, what is a magnet? What are the different kinds of the magnets? What are the properties of the magnets? Then, what is a right hand thumb rule? Then, draw the magnetic lines of force for the bar magnet, circular loop, straight conductor, as well as solenoid. Okay, so you will try to find out these answers. These are direct questions. These are direct questions from whatever topic I have completed with you. Then you can find the answer for how does a freely suspended magnet align itself, means in which direction. Then explain with an activity the arrangement of the magnetic field lines in a straight conductor, means with an activity, how do we come to know that, what are the arrangement of the field lines. Then you can write any two properties of the bar magnet. Then one question is, what is a magnetic field line? What is a uniform magnetic field line? These type of lines are uniform magnetic field lines. So today you will go through my videos, all the videos. Even if you have not seen the previous videos, please go through those videos and write down these questions. Complete these notes in your notebook. Yesterday also I had sent one page on which I had written about the circular loop. I hope you have completed this. And in the next, that is tomorrow, I'll start with a new topic. So children, if you study on time, you will be able to understand the chapter. Otherwise, you will have 100 doubts in the end. So my advice to you is, my request is, please study regularly, as it is your board class. Please manage your time properly, and if you have any queries or doubts, you can ask me. Okay, any doubt, feel free to ask me. You can send me the message on my personal number. Don't feel shy. Okay, if any doubt you have, I will clear your doubt. Okay, thank you.